All right, so Miss Whitney,
Yes, ma'am.
could you please remind us what our three states of matter are? What are our three states of matter?
Solid, liquid, and gas.
Solid, liquid, and gas. Very nice. Thank you very much. So if you knew that, you're well on your way, hopefully. Hopefully at a minimum, you know solid, liquid, and gas, okay? Let me just move this so I can see everyone. All right. So Whitney says solid, liquid, gas are our three states of matter. All right. Um, Matter, I'm gonna try to write on my screen here. All right. Matter is what this whole unit is, okay? Matter is anything that has mass and volume, okay? Matter is anything that has mass and volume. Now, let me tell you the difference between those two. Volume is how much space you take up, okay? So if I spread whatever room I'm in or area, however much space I take up, that is what your volume is. So that's why gases volume can change. If they can be in a tiny little can and be compact, or you can open that can and they can spread across the entire room. Or like if you blow up a balloon, okay? Mass is very similar to weight, but it's different. And I don't want you necessarily to focus on that, but I just want you to know you can kind of think of it as weight. Mass is how much stuff we're made of, okay? So realistically, when people say, I would like to lose weight or I would like to gain weight, what they really mean is they would like to lose mass or gain mass because weight depends on how hard gravity is pulling on you. So what I weigh in South Beach may be different in the Rockies, and it's definitely different if I'm on the moon because it depends on how hard gravity is pulling on you. Yes. Uh, yes. Yes. Okay. All right. So matter is anything that has mass, okay, has mass and takes up space, which essentially is everything, right? Everything, even air particles take up space, right? And it's right next door, okay? All right, so that's what you need to know about in terms of the definition of matter, okay, and mass and volume. Law of conservation of mass, I added that. That's just the one that's saying matter or mass cannot be created, nor can it be what? Destroyed. Very good. Okay. Can't be created nor destroyed.
That's the law of conservation.
Yes. Okay. Cannot be created nor destroyed. Okay. Now there is an extension to it because you're like, well, how can you not create it or destroy it, but it looks different? Well, it can change forms. Okay. It can transform, but you can't just magically create anything or destroy it. It already exists. Okay. So far now we have covered matter, mass, volume, law of conservation of matter, and Miss Whitney told us the three states of matter. All right. Let's say, Fisher, if I asked you which state of matter has indefinite shape and indefinite volume, which one would you tell me? Gas. Very nice. Fisher said gas. Indefinite shape, indefinite volume. For these three, you need to know about their shape and their volume. Okay, it's either defined or it's not defined. Okay. Sid, are you there?
Yes.
Okay. Cedric, could you tell us which one has a definite shape and a definite volume?
Solid.
Solid. Very nice. Solid has a definite shape and a definite volume. They cannot change. Okay. I cannot take a book and squeeze it into a cup. It's not going to change. It's not going to change shapes. Okay. All right. Now, a liquid is the only one where it's half and half. One of them's definite and one's indefinite. Which one can change, Eric? Is it the shape or the volume of a liquid that can change?
The shape.
The shape can change, not the volume. If I've got 10 ounces of Coke, I've got 10 ounces of Coke. I cannot squeeze it into a 5-ounce cup. It is going to run over, okay? So this is the only one that has an indefinite for one and a definite for the other one. And this one is an indefinite shape. Look, we're like a third way through our list already. I told you guys knew way more than you thought you did, all right? Let's go down to, let's do it in the order that we learned. Okay, let's talk about phase changes. Phase changes, phase starts with a PH. Phase changes are always physical changes, okay? Phase changes are always physical changes. Miss Jamie, are you there?
Yes.
Okay, Miss Jamie, could you tell me one of the 6 phase changes? One of the 6. Any one you want. So that's like going from a solid to a liquid, or a liquid to a solid, or a gas to a solid, or a solid to a gas, or a liquid to a gas, or a gas to a liquid.
Condensation?
Condensation, thank you very much. That is one of the 6 phase changes, okay? Condensation. All right. Irvin, can you give me another one? Another phase change, please. So far we have condensation. Okay, I'll come back to you. Isaiah, you got one for me? Say again? A phase change. So far we got condensation. Need me to come back to you? Yeah. Okay, I'm coming back to both of you. Dominic, can you give me a phase change, please?
Me?
Yes, you.
Okay, deposition.
Deposition. You know what? I knew you were going to go with the hard one, Dominic. Deposition. Very nice. All right. Ennis, how about another one?
Boiling point.
Boiling. Very nice. Boiling. We have 2 other names for this. Anybody remember one of them?
Evaporation?
Yes, boiling. Evaporation is another one. And then there is one more that sounds like evaporation.
Vaporization.
Very nice. Vaporization. All right. Those are all the same thing. All right, Urban, Isaiah, you guys there's only 3 left. You guys owe me 2, or owe me 1 each. That one? Sublimation. Thank you very much. That's very nice. Sublimation. Isaiah, look how nice everyone was. They left you the 2 easy ones. We got that one already, though. 2 easy ones. Solid to liquid. Oh, let me bring up a good point. All right, so let's say right now, okay, let's say you were on your quiz or your test, and you're like, I know I'm forgetting 2. I cannot remember which ones they are. Go through and let's look at which ones we have, okay? Condensation, where are you going? Where are you starting, and what are you going to if you're in condensation? Liquid to gas. Very nice. All right. What about, I think boiling's the next. Wait. Boiling. What's boiling? Wait, hold on. Let's go back, Joe. Boiling.
Boiling is liquid to gas.
Boiling is liquid to gas.
Condensation is gas to liquid.
Very nice. Condensation is gas to liquid. All right, he corrected himself. Fantastic. Now the 2 hard ones are deposition and sublimation. Anybody know which one? Sublimation is usually the one I remember, and then I just process of elimination. Solid to gas for sublimation. Very nice. Deposition is
Gas to solid.
Wait, what is it called when it's like like when you're swimming a drink and like water comes out the side?
yes. All right. So Joe said, what is it when you have your glass and it's like wet on the outside? You might remember what that one is?
I thought that was condensation.
It is condensation. Okay. So, and let me explain condensation, and we'll go back to these last 2. Okay. Condensation, there is air around us right now, okay? When we talk about humidity, right? When you go outside and it's like in the summer when it's super humid, you go outside and you immediately start sweating, right? Because we're in Georgia. That is the air is cooling off on your body and it turns into a water, okay? So sweat actually is meant to cool off our bodies because we're so hot, okay? But condensation on your glass is gas particles hitting your glass, because you don't have condensation if your drink's hot, right? It's only if your drink is cold. So the air hits the glass and it's like, ooh, that's cold. And it cools down, turns back into a liquid. All right, so again, let's say you're on your quiz. We've listed 4 of the phase changes, okay? We've listed 4 of the phase changes. We have gas to liquid, liquid to gas, gas to solid, and solid to gas. So just tell me, what are we missing? Going from what to what?
Liquid to solid.
We're missing going from liquid to solid and from solid to liquid, which should be the easy ones. Now that you know that, what are we missing?
Freezing, melting.
Very nice, freezing and melting. So if you get stuck on your quiz, you can go and say, okay, I've already done gas to liquid, liquid to gas, see what you're missing, and that should help you figure out what phase change you're missing. All right, liquid to solid, is that one freezing or melting?
Melting.
Solid. Liquid to solid. Somebody said it. Freezing, yes, freezing. All right, and that must mean this one must be melting.
What's an example of sublimation? Did you already go over that?
An example of sublimation, the coolest one is dries. So I will only give you 1 or 2 examples because we don't do a lot of sublimation. So it's either iodine, gas, or I probably would use dry ice.
What about deposition?
I probably won't even give you that one.
Okay.
I may want you to know what it is, but I probably won't give you an example because the only deposition I really know is iodine crystals turning back into a gas. So we don't see that phase change a whole lot, but we see all the other ones, okay? All right, so now we've covered phase changes as well, okay? So phase changes, all right? And there's one other thing I want you to know for phase changes, okay? You should also know on which one of these am I adding heat and which ones am I taking heat away. So for instance, let's start with one that's super easy. If I'm freezing, am I adding heat or taking heat away?
Taking heat away.
Very nice, taking heat away. So this one is minus heat, taking heat away, all right? If you know one, you can do the opposite for the other one, right? If freezing is liquid to solid and I'm taking away heat, melting must be adding heat. Does that make sense? They're opposites. All right? Now, here's what I want you to remember. As long as you are going towards a gas, okay, as long as you're going towards a gas, you are adding heat, okay? As long as you're going towards a gas, so towards a liquid or towards a gas, you are adding heat. So what other ones are also adding heat?
Sublimation.
Sublimation.
And boiling point.
And boiling. So that means those 2 top ones, number 1 and number 2, if you wrote them in the same order as me, those 2 top ones are losing heat, okay? Those are losing heat, okay? All right, I'm gonna give everyone a second just to catch up if you're writing. These are plus signs, sorry, that doesn't say heat. It's a plus sign, okay? So this is a plus heat. Plus heat, okay? And this one's minus heat. This is also minus heat and minus heat. Okay. At this point, we have probably covered 40% of the test or quiz. 40%, that's a good percentage, okay? So you're doing pretty good so far. Now, those are phase changes. phase changes are physical changes, but they aren't the only physical changes. What else could I do to physically change something? What could I do to physically change a piece of paper? I could what? I could rip it. If I rip something, crush it, tear it, fold it, any of that stuff, so long as whatever I do to it is still the same thing. In other words, it's still a sheet of paper or it's still a rock. I can take a rock and I can crush it. It's still a rock, it's just smaller rocks, right? Then it's a physical change, okay? Let me see what I checked here. Okay, all right, so we have covered matter, mass, volume, law of conservation of matter, states of matter, phase changes, solid, liquid, gas, phase changes, and physical changes. We've covered a lot, okay? So now let's focus on physical properties, chemical properties, physical changes, chemical changes, okay? The first thing I want you to know is the difference between a property and a change. All right, prepare to be mind blown. Are you ready? If it's a change, you had to change something. I know, amazing, right? If it's a change, you actually had to change something. In other words, you had to do something, okay? If I say flammability, did I do anything? No. If I say I set something on fire, did I do something? Great, that's a change, okay? Physical properties are going to be things that have to do with your 5 senses. Okay? 5 senses. How does it look? How does it taste? How does it smell? How does it feel? What does it sound like? Okay? All right. Eric's shirt is great. Joe smells great today because he took a shower. Okay? Those are things that, or the chips are salty. Okay? My shirt is soft. How does it feel? Texture, color. The bell is loud today. Okay? The school is loud today because there's people in there. Okay? So those are the type of things, those are physical properties. Okay? And I did not say I changed anything about it. Texture, if it feels soft, I didn't change anything. I just said it feels soft. Okay? So that's physical properties. Chemical properties are stuff that if I were to do it, I didn't say I did it, but if I were to do it, or if it's some type of property, then it would change. For instance, a lot of them end in the word ability. Flammability. Combustibility. Okay? The ability to rust. The ability to tarnish. Reactivity. Okay? So those are a couple. Flammability. I'll say them again if you want to write down a couple of them. It's up to you. Flammability. Combustibility. Reactivity. Okay. The ability to rust or tarnish. Okay, which basically means the same thing. Here about that. Okay, those are chemical properties. Now, to tell you the difference between a chemical property and a chemical change, flammability means what? What does flammability mean anyway? It can catch on fire. Now, a chemical change would be, I set it on fire. Okay? There's a difference between saying it can catch on fire and me saying, no, I set it on fire. Okay? One is a property, flammability, the ability to catch on fire. I set it on fire. That's a chemical change. I did something. Okay? If you have a chemical change, you should create some new stuff. Okay? If I set something on fire, I got a lot of new stuff. I got light, I got heat, I got ashes, I got smoke. I'm gonna get that typically no matter what I set on fire, right? Or some type of explosion. All right, questions about physical, chemical properties or changes? Anyone? No one here. All right. Connected to chemical changes is evidence of a chemical change. So these are questions you can ask yourself. Did I see any of this stuff when it changed? Okay. These are the differences. Remember we had the old grandma's country pies taste lovely. Okay. So I'm gonna, let me save this. Okay. Anybody still writing anything that I have up? I'm about to clear the entire screen. Are they still writing? Yes? No? Okay. Joe, you still writing anything over here? Okay. Nobody online? Okay. All right. I'm gonna clear everything. We've covered this.
Science rules.
That's right. You already know. That guy's hilarious. All right. So we've covered all of this. You know what? I should have scrolled down first. That's okay. All right. So we've covered all of this. Oh, and we're on this. Okay, we're covering this. So remember, each of these stands for something. The O stands for something, the G, the C, the P, the T, and the L. They all stand for something, okay? And remember, like I gave you, I'll tell you 2 good examples of chemical changes where you would see a lot of this stuff. My favorite, cooking, okay? Really my favorite is eating, but you know, you gotta cook first before you can eat, all right? And then fireworks, okay? So cooking and fireworks. Great examples of chemical changes. And you see a lot of these things or notice anything. Does anybody remember any of these letters? What any of them represent? Yes.
Odor for the O.
Very nice. The O is odor. Thank goodness. Cooked chicken does not smell like raw chicken. I don't know if you've ever smelled raw chicken before, but it is not something that smells appetizing. I would not want to eat it, okay? So thank goodness there is a change in odor, okay, when we cook chicken, okay? If something changes in odor, for instance, if you've ever smelled bad milk, it didn't smell like that when it was good, that's an odor change. You had a chemical change take place, okay? All right, let's see. Faith or Cameron, do any of you guys remember any of these other letters? G, C, P, T, or L? Remember, you can think about, say again?
Gas.
Did you say mass?
No, gas.
Oh, yes, gas. Gas is one, all right? And typically when we see gas, what are we actually seeing?
Bubbles.
Bubbles, very nice. So you know how if you look at those, sci-fi movies and they're like throw acid on somebody and they're like, I'm melting, and they like start bubbling and all that stuff. Bubbles, that is a chemical change. I think the Hulk bubbled, maybe not. No, he didn't. Did the Hulk bubble? I don't think he bubbled. But he had a color change. Yes? Color change, that's another one. That's the next one, I just thought about that. All right, the Hulk definitely went through a chemical change because he changed colors. He became green, okay? Again, thank goodness, cooked chicken is not the same color as raw chicken. I would not want to eat it. All right, I would do P because that's the hard one.
Precipitation.
Ooh, somebody knew it anyway. Yes, a precipitate. So that's the one where you get 2 liquids and then somehow they magically turn into a solid. That magic being science, okay? And we'll talk about if we get to it. later in the year how that happens or why that happens.
What do you mean by two liquids?
So remember we took those two liquids
Yeah,
and we poured them together? Yep. And so I actually still have some of the tubes back here. Oh, if I can reach it. And so remember it turned yellow, and then you can see that powder is still in there. So it was two liquids, we mixed them together, and then we made a little powder in the bottom. Yep. Powder at the bottom. Powder. If you're looking at my screen, there's a powder at the bottom. All right, so that's the precipitate. All right, mix two liquids together and we got a powder. What to do with this? All right, so we got two letters left, T and L. Definitely can see these with fireworks.
Touch.
Not quite.
Temperature change.
Very nice, and it's yes, temperature change. Again, same thing with food. Thank goodness. I wouldn't want to eat chicken that's. Ugh. Yeah.
Light.
And what'd you say, Whitney?
Light.
And light. Very nice. Okay. If you see any of these, a change in those, you definitely had some type of chemical change. If there's a change in odor, if you see bubbles, if there's a change in color, okay, or precipitate form, or a change in temperature, like a hand warmer or ice pack, okay, or light is produced, like a glow stick, then you had a chemical change. Now, I want to be very clear again. Just want to use this as an example one more time. If I say color, and I ask you, is that a physical property, chemical property, physical change, or chemical change? Take a second. Don't say it out loud yet. I want you to think about what you think that is. The word color, okay? Anybody feel confident in their answer? What do you think?
Physical property.
Eric says physical property. Should we agree with him?
Yes.
Yeah.
Yes, you should. If you're smart, you will agree with him because I did not say I did anything. Color, if I say color, I'm just asking you about the color of something. The red balloon, the green grass, the blue sky. Now, if I say color change, should I answer stay the same or should it change?
Change.
It should change. What should it change to? Anybody? Now I have color change. Should that be physical property, chemical property, physical change, chemical change?
Chemical change.
Very nice. This one's a chemical change because that's an evidence of a chemical change. Very good. So this color change, like when you burn your cookies that you bake at lunch, that would be a chemical change, okay? And I would not want to eat burnt cookies. All right. Questions so far? All right. I'm gonna save and I'm gonna clear. All right, here is what I think most people are going to struggle, okay? Let me scroll a little bit so I can see. All right, here's where I think most people are going to struggle, and I'll tell you why. Most people are going to struggle right in this box. Why, you ask? Because so many people did not do their homework, okay? This was the matter concept map. So you have matter at the top. So if you did this, you're sitting pretty, right? And then you had a box here, and then you had a box here, and then from here you had two more boxes. Down here you had 3 boxes. Okay? For this, you need to know the definition of an element, a compound, homogeneous mixture, heterogeneous mixture. Solution, colloid, suspension. For these, you really just need the particle size. So you should know which ones are the biggest and which ones are the smallest. Okay. This is another just definition. And the most important thing is you need to know which ones can be physically and or chemically separated or not. Okay. This is probably gonna be the hardest part of the test. This is the thing that people tend to miss. Okay.
Are we
And
gonna
it's-
go over the definition?
Say again.
Are we gonna go over the definition?
Yep, I'm gonna go over it right now. But most people miss it because they just didn't do it. Yes, Fisher.
What percentage of the test is that stuff?
I would just make sure that you know exactly what we're about to talk about. So you should know this, and you should know like what compounds 2 or more elements. You should know mainly is this. I would say it's mainly this. Because this flow chart is based off of this. Okay, that's what it's based off of. Okay. So let's go through this. All right, again, we've covered everything up until this. And then there's nothing left for separation techniques, and that's pretty easy. I'll talk about that in a second. All right, and then we'll close out with Kahoot. All right, I will tell you, over here is pure substances, okay? And in this box is mixtures. All right, so if you do not have this down, make sure you are getting this down, okay? I'm not gonna write everything, but just listen carefully, okay? Give you a couple seconds.
What's the word on the
Mixtures. Yep. All right. Here's what you need to know. Let's start with what I think you would know. There are 2 types of mixtures. What are they? Very nice. Homogeneous and heterogeneous, all right? There's 2 mixtures, homogeneous, heterogeneous, okay? So over here is, they're not in the boxes down here, but technically homogeneous is called something else. And then these 2 right here are both heterogeneous mixtures, okay? All right. There is a word that literally means homogeneous mixture, okay? Now, if something is homo, does it look the same or does it look different?
Same.
Same.
Same, okay? Now, think about this. If one of these, okay, when I say one of these, I'm referring to these guys. If one of these is a homogeneous mixture, which means it looks the same throughout, which means I cannot pick out the different pieces. Do you think the particles are very big or very small? If they look the same
Small.
throughout. They're very small, okay? Very small. So small that I cannot tell there's different stuff mixed together. It looks the same, okay? It looks the same. Who of a solution, colloid, and suspension would look the same throughout and have the smallest particles?
Solution.
Very nice. Solution. All right. You have to know, everybody listen, you have to know that a solution and a homogeneous mixture are the same thing. The definition of a solution is a homogeneous mixture. That's what it is, okay? That is a solution. A solution is a homogeneous mixture. And the reason why it looks homogeneous is because the particles are the smallest that you can get. Okay? So now we've done homogeneous and solution, okay? These are listed in order. So therefore, who has the biggest particles? Remember I said you go to the store and if you look at this stuff, there's a lot of these. What is it?
Suspension.
Yes, remember I said in the store, a lot of times, what would the bottles that have suspensions, what would they say?
Shake well.
they will say shake well. If you've ever bought like a naked juice or a protein drink, or even like fresh squeezed orange juice, you definitely need to shake it. Italian dressing, please shake that before you use it, okay? The particles are so big that they settle at the bottom. So you need to make sure you shake those well, okay? So these are the biggest particles. And that just means colloids in the middle. All right, solution, colloid, suspension. They are listed and are in increasing size of particles, okay? And we said if homogeneous means they look the same, heterogeneous means it looks different, correct?
Different.
Exactly. So think like when I think heterogeneous mixtures, I think stuff that wildly looks different. Chopped salad, trail mix. You can see all the different pieces, okay? All right. Or even fresh squeezed orange juice. You can see the pulp. You can see the difference. All right. So that is on that side. Mixtures can be physically separated. I can physically separate a solution. I can physically separate trail mix. Now, Irving, on the other side, what would I have? Irving, you're gonna have a new seat on Wednesday. All right, on the other side are pure substances, okay? One of them cannot be physically nor chemically separated. What you got is what you got, and you cannot break it down anymore. And then,
Element.
what is it?
Element.
Very nice. Element, okay? It doesn't matter which box it is, as long as you know that you cannot physically or chemically break it down, okay? So no, you can't do it physically, and no, you can't do it chemically. What you got is what you got, okay? I cannot take copper and say, I'm gonna break it down into anything. Copper is copper. I can't break it down. Now, what does that leave us with? We've done everything except for
Compound.
compound. Very nice. A compound, you must know the definition for that. It is two or more elements stuck together. I cannot physically break it apart, but I can chemically break it. So no for physically, yes for chemically, okay? I cannot take H2O into my hand and separate it back out into hydrogen and oxygen. I wish I could. I would not be teaching. I'd make a lot of money, okay? But I can't. I cannot take sugar and physically separate it back into carbon and hydrogen and oxygen. I can't separate table salt back into sodium and chlorine. I can't, okay? Chemically, I can. Probably requires some type of heat or electricity, but I can't do it physically, like with my hands, okay? All right, so the only other thing that's missing here is an alloy. It is a mixture, specifically a homogeneous mixture of two what? We talked about it before. Bronze and brass and steel. Mixture of two what? Metals. Very nice. Mixture of two metals. We're almost to break time. All right, the last thing I need you to know, okay, last 2 or 3 things, okay, is separation techniques. Now, separation techniques are physical ways to separate something. What's the only thing I can physically separate? Mixtures, okay? So this is how can I separate different mixtures, okay? So this is for mixtures, all right? I did not give you, there's a list in Schoology. The ones on here are the ones that I want you to know, okay? Magnetism, pretty easy. It's gonna pick up stuff that is magnetic. Questions about that one? Hopefully not, okay? Evaporation is exactly what it sounds like. I can get rid of the water and whatever was in the water is still there. So like salt, right? I can evaporate water from salt water. All right. Filtration. Anybody remember what I said my favorite type of filtration is? I do it every morning. Coffee. All right. So this is like coffee or when we filter our water. Okay. even like the water pitchers in your house or in your made into your refrigerator door, they filter out stuff, okay? Usually it is separating a solid from a liquid. When I cook spaghetti on the stove, I don't like to eat wet noodles, so I usually pour the water off and I put my spaghetti noodles in a colander or a drainer, right? Pour it all in there. The water goes through the holes. The spaghetti stays in the bowl. And I think I'm Italian. And it's fantastic, okay? So that's filtration, usually separating a solid from a liquid. My writing's terrible too. All right. Does anybody remember screening? I said you may have talked about it in history class. Those people back in the day were looking for stuff. What were they looking for?
Gold.
Gold, right. If you sift it, big stuff stays on top, little stuff falls through the hole. That's screening, okay? All right. Anybody still working on that matter concept map? Because I'm about to clear the screen. Okay. All right, here are the two I want you to make sure you know. I think everyone is going to need to write this down, okay? There are two more. One is distillation, and the other one is centrifuge. These are the two that I want to make sure you know, all right? One is separation based on boiling point. The other one is separation based on density, okay? One is based on separation points, one is based on density, okay? All right. Does anybody remember which, what industry uses distillation? I remember what I said. This industry is known for using distillation. They make a lot of money, let me tell you. Yes, alcohol. So alcohol, beer, liquor, all that stuff, they use distillation. Now those are all liquids. Which one do you think that is? Is that the one based on boiling points or based on density? Any guesses if I'm separating out different liquids?
Have you not seen my Head and Shoulders shampoo?
I have not seen your Head and Shoulders shampoo.
Oh, I'm sorry.
That's okay. All right.
Destiny.
Distillation is the one based on boiling point. That's the really complicated looking setup. Okay, the complicated looking setup where you have a couple of things and you heat something up and then it cools back down going through that tube and everything. Okay. Centrifuge. If I say anything about centrifuge, I will probably refer to the hospital where they separate your blood from your plasma. Okay. So if you see me say something about blood and plasma, okay, that one is centrifuge. That's based on density. In other words, that's the machine spins stuff really, really fast. Heavy stuff goes to the bottom of the tube, light stuff goes to the top. Okay. All right. Last two things, then we're gonna take a break. Small break. If you do not know this, and I put it on every single homework question since we've started this unit, and somebody's still gonna miss it. I already know on the Kahoot. Dissolving, is it physical or chemical? It's probably not what you think.
Physical.
Thank you. Yes, thank you. Dissolving is a physical change. You have to know that. Only because I've asked you like 12 times and people still miss it. Okay. We've already done this. This is another question I'm telling you I'm going to put on the test. Filtration will not work with the solution. Yes, the solution is a mixture, but it won't work with, filtration won't work with the solution because the stuff is too small. It will go through the pores. Okay? And we've already talked about that last week. All right. 7-minute break to stretch your legs or do whatever you need to do. I would also advise you to possibly consider on your break scrolling through this study guide and seeing if there's anything you do not know the answers to. I'll leave it on this screen and scroll here, okay? For 7 minutes, we're gonna start the Kahoot at 2:15.
I didn't stretch this morning.
Why did you not stretch this morning?
That's bad.
You're supposed to stretch when you wake up.
It's hard to remember.
Miss Payton,
Yes, sir.
you said that hetero and homo mixtures can be separated physically.
Yes, they can. We're almost there, guys. 21 more minutes. Anything else? Mm. I'm scrolling through the study guide just in case you have questions. I also had everybody show up for first class. I had two kids that showed up at 9 o'clock. And I was like, how are you in class for 9 minutes? Oh, because Virgil said that. Yes, that's a 10:45. Yeah. So, that was interesting. Yeah. Let's see though. And then I had, I think I had 7 kids. First class, good. And then I had a lot of second class. I'm just kidding. I gotta stop doing that. Before I get back to you. But it's very interesting. For sure. So, you know, in my friend's class, we had class through Zoom. So that's what I feel like. I don't understand why I was so I feel like that would be. Yeah, it was. I mean, the teacher wasn't there though, so I don't know. Like, I don't know why she wasn't there either. But we have to be there. And then my uncle's dad got there, and he didn't let us use their phone. So he went in there and picked his phone. The phone thing is not too bad. Yeah. Really, like, unless it's like. Yeah. Other than. Fisher, when you spell your name, do you put a T in there? Or no?
No, FISH. No,
That's Joe. Okay. He won state this weekend. He ran so fantastic.
remember our deal, Miss Payton?
Yeah. I remember. Did you really? I'm assuming that was accidental.
I hope so. I wanted for like I wanted for to tackle one. I guess because it like landed on.
Oh my gosh. That's crazy. Got about 2 more minutes. I am scrolling through the study guide. I'm so much like I just drink this and went down the wrong side. So now I'm like coughing, so
Can you do 13 through 18?
yes. Okay, so different boiling points. Which one is that, you think? We just talked about the boiling points one. Do you know which one is boiling point? Which one of these?
Distillation, A.
Salt-proof water, that one would be evaporation. 14 would be evaporation. Stand from water, I would use filtration for that one. If you have iron filing, a magnet will pick that up. So that would be a magnet. And then I just told you if I say something about blood or hospitals, which one would that be? Or if I said density. So you got
One with the C.
Yes.
The
a centrifuge. Yes, that one. And then this last one, I wouldn't ask you about this, but this one is chromatography.
Okay.
Okay. The last thing, guys, really quickly before we start this Kahoot is there is a little bit of an overview on here, like mainly like sig figs and like accuracy and precision, because I did make a deal with you guys that if you did better on this test, that I would replace it. So I won't, yeah, I'll figure out how I'm gonna grade that. And then these are the last few questions. And now we're gonna Kahoot for the last 15 minutes of class, so hopefully not too bad. All right. Here we go. Time to Kahoot. We're ready to join. reminder, really quick. You will be quizzing on Wednesday. So come in, I might give us maybe 5 minutes, then we're gonna quiz. And at most, I'm gonna give you an hour. Depends on how long the quiz is. And then we'll go over the quiz. That's all we're doing on Wednesday. Quiz and review. And then on Monday, you guys take the test. Nice job. All right, those are all types of mixtures. This is what I mean by knowing that matter concept map. Nice job. Questions? Very nice. Air is a mixture of gases. Nitrogen, oxygen, CO2, carbon dioxide. Oh, wait, that is. All right, here we go. Nice. Most people got that element. Good. That's one of the questions that I'm worried about you getting. So that's good. Got some answer streaks. Really asking you, what is calcium chloride? That's what I'm asking. Very nice. There's definitely more than 2 elements, so that is a compound, or at least two elements. Liquid to solid. Nice. Oh. All right, if you got a bear, I'm trying to separate a solid from a liquid. Separate. All right, so remember, this is the alcohol industry. Solid from a liquid, that's from the spaghetti in my coffee. All right, a diamond. Ooh, some shifting going on. Melting popsicle. job. It's a physical change. Something actually happened. No one picked chemical though, so that's good. Liquids have a definite. Very good. At most, we haven't talked about anything about temperature or pressure. All right. So this is about something bendable. What is that? Very nice. If I bend aluminum or lead, it's still aluminum or lead. So that's just a physical property. Boiling point. That's boiling point. Ooh. Boiling, first of all, is a phase change, so we should not have picked chemical for either of these, right? Because boiling is a physical thing. And I didn't say we actually boiled it, I just said boiling point. So that's like saying water's boiling point is 100 degrees, or alcohol's boiling point is 125. It's just something you know, a property. Combustibility. Combustibility is a property. If something combusts, that means it can set on fire. That's a chemical property. Okay, we didn't actually do anything, so it can't be a change. Camera with the streak. Trying to get to some good ones. Ooh, gas to a solid. Very nice. Gas to a solid is deposition. Solid to a gas is sublimation. On the periodic table. Which of these is not a phase? A phase. I always trick someone with this. Condensing is the same thing as what? Condensation. Very nice. Interesting. Very nice. All right, which one cannot be broken down chemically? Can't be broken down. see if we can get to 20. Substances cannot be broken down. Even pure substances are compounds and elements. Cannot. Cannot be broken down physically. This is elements and compounds. They fall under pure substances. All right, let's see if we can get, oh, let's do one more question. This will be it. Last question. Color, just color. Last question. Very nice. Copy. All right, be ready for your quiz. You guys made it to your first day. The bell to ring.
Since you all want to create them, you can write that.
I do get a ring. Joe wanted me to have a ring my first year, so
You're all good.
thank you. Okay, bye. See you guys. See you guys Wednesday. Huh? No, I got class today. See ya. So nice